When the lights go out across a major city, our minds naturally jump to the plot of a thriller. We imagine a highly sophisticated hack, a rogue nation-state, or a team of digital terrorists systematically taking down the grid. It makes sense to assume this. We live in a highly connected society where nearly every piece of critical infrastructure is tied to a network. We are constantly warned that our greatest daily vulnerability is digital. But if you ask the people actually defending the system, the answer is completely different. In 2015, the former deputy director of the National Security Agency identified the actual #1 threat to the U.S. grid: ordinary squirrels. This statistical reality spawned the Cyber Squirrel 1 project. It operates as a data-driven security database created to track what researchers call unclassified cyber squirrel operations, essentially logging every confirmed time an animal takes down our infrastructure. Comparing operations, human-led cyber attacks sit firmly in the single digits. Meanwhile, the database tracks thousands of blackouts caused by animals. The financial toll is staggering. They leave 13 million Americans without power every year, costing $10 billion annually in damages and loss activity. Cyber warfare remains a serious theoretical risk, but the physical reality is that nature successfully dismantles our infrastructure every single day. Substations and utility poles are highly attractive to wildlife. They offer a high vantage point away from predators, and the humming electrical equipment provides a reliable source of warmth, especially in the cold, early morning hours when animals are foraging. To understand why this is a problem, look at the hardware. High-voltage distribution systems rely heavily on air to act as an insulator. That means they feature exposed metal wiring and very tight spacing between components. This design creates a deadly obstacle course. A short circuit happens when electricity is diverted from its designated path. If a curious animal touches an energized wire and a grounded surface at the same time, its body acts as a conductive bridge. The high-voltage current instantly surges through that biological path. This massive overload immediately blows the system's fuses to prevent wider damage, severing power to all the homes and businesses on that circuit. The economic fallout from one of these tiny bridges can scale quickly. In December 1987, a single squirrel in Trumbull, Connecticut, infiltrated a local substation and short-circuited the hardware. That specific substation happened to power the NASDAQ computer center. The resulting 82-minute blackout completely shut down the exchange floor, preventing the trading of roughly 20 million shares. Our highly advanced, globally connected digital economy is entirely bottlenecked by the physical vulnerabilities of outdoor hardware exposed to local wildlife. While mammals and birds cause outages through individual physical contact, invertebrates disrupt the grid through sheer volume. Massive coastal blooms of jellyfish are routinely pulled into the ocean intake pipes of nuclear power plants. Their gelatinous bodies pack together so tightly that they physically clog the critical cooling systems, forcing operators to shut down entire reactors. On land, certain species of ants are magnetically drawn to electrical fields inside pad-mount transformers. When the first ants wander in and are electrocuted, they release alarm pheromones. This chemical signal summons thousands of other ants, creating a conductive biological mass that shorts out the equipment. This chart visualizes the documented causes of failure for subsea internet cables. For years, viral videos convinced the public that sharks biting cables were a major threat to global data. The data shows shark bites actually account for exactly 0% of total faults. The actual primary physical threat to our underwater data infrastructure is human industrial activity. Up to 75% of subsea cable blackouts are caused by commercial fishing gear and heavy ship anchors dragging across the seafloor. Defending the grid requires a strategy that looks beyond individual physical contact. Success depends on managing the massive, unpredictable shifts across the entire biological environment. In sub-Saharan Africa and South Asia, this biological intersection carries severe ecological consequences. Sprawling rural power grids are expanding directly into the native habitats of large local megafauna. Because these networks often feature sagging or low-hanging lines, the animals are both the cause of the blackout and the victims. Endangered species, including adult elephants and giraffes, are frequently killed when they accidentally make contact with the conductors. Further up the poles, large birds of prey pose a unique dual threat. Their wide wingspans easily bridge the narrow air gaps between energized wires, and the massive nests they build directly on top of utility structures accumulate highly acidic droppings that corrode expensive components. To stop these interactions, utility companies are actively hardening the grid. Engineers are blanketing substations and high-voltage lines with advanced weather-resistant polymeric materials to physically separate the animal kingdom from electrical currents. They also deploy behavioral deterrents: free spinning wheels to block squirrels, specialized fences to stop snakes, and fake owls to scare rodents. It is a continuous evolutionary arms race. Utilities are forced to combine advanced material science with a deep understanding of animal psychology just to keep the lights on. The most modern utilities are now shifting to a proactive strategy. Using predictive analytics, they track biological patterns, like squirrel dispersal or jellyfish blooms, and deploy defenses before the seasonal incursions begin. This philosophy of informed resilience, along with standardizing wildlife-friendly infrastructure globally, actively reduces utility repair costs while simultaneously protecting local ecosystems. We treat our electrical grid like an isolated engineered machine, but a secure digital economy relies on acknowledging that our technology will always be embedded within a wild,